Hello everyone, I'm Marihan. My topic is about Antilock braking system. Okay, this is the project which I have taken the automotive system course. Let's get into the topic. Introduction: An anti-lock braking system is a safety and anti-skidding braking system used in aircraft on a landing vehicle such as car, motorcycles, trucks, and buses. ABS operates by preventing the wheels from locking up during braking, maintaining the active contact with the road surface, and allowing the driver to maintain more control over the more control over the vehicle. Actually, it also avoids the wheel lock in the slipping condition, and during the ice road, it also avoids rolling of the wheel. Okay. Next slide. Concept of ABS. So the theory behind the anti-block brake is simple. A skidding wheel, a tire where the tire contact patch is sliding related to the road has been traction, then a non-skidding wheel. If the wheel have been stuck on ice and if the wheel are spinning in them, the vehicle have no traction. This is because the contact patch is sliding related to the ice. By keeping the vehicle from skidding while you slow down, anti-block brakes benefits you in two ways. You will stop faster and you will be able to steer while you stop. Good drivers have always pumped the brake pedals during the panic stops to avoid wheel locks and the loss of control. But ABS simply get the job done very easily. Now we'll go to the principle of ABS. The brakes of the vehicle not equipped with the ABS will almost immediately lock the wheel when the driver suddenly applies the brake. In the case, the vehicle slides rather than roll to a stop. This skidding and lack of control was caused by locking of wheels. The release and reapply of the brake pedal will avoid the locking of the wheel, which in turn avoids skidding. This is exactly what an anti-lock brake system does. Now we come to some of the main ABS components. The main component of ABS are hydraulic component and electrical component. So first you can go to some of the hydraulic component. Hydraulic component consists of accumulator, anti-hydraulic control wave. So now we go to the booster pumps also present in the assembly, hydraulic control circuit unit, main valve, modulator unit, solenoid valves, etc. We have many hydraulic components. Similarly, in electric component, hydraulic components which will be present without ABS or with ABS. So the electric component is the most important part of the ABS component. So electric components, electric component as ABS control module. What is ABS control module? This is a small computer is normally mounted inside the trunk on the wheel housing, mounted to the master cylinder. Or the hydraulic control unit. It monitors the system operation and control anti-lock function when needed. The module relies on input from the wheel speed sensor actually and feedback from the hydraulic unit to determine if the ABS is operating correctly and to determine when the anti-lock module is required. This is one of the main component in the. And as we know, there's a brake pedal sensor. Obviously, it should be there. The brake pedal sensor, anti-lock brake pedal sensor, which is normally closed. When the brake pedal exceeds the anti-lock brake pedal sensor, this is getting during an anti-lock stop. The anti-lock brake control module sends that the anti-lock pedal sensor switch is open and ground the pump motor relay coil. So you can see here also we have a pressure differential switch and relays, tooth ring, wheel space sensor. So now we can go to the relays. Relays are electromagnetic device used to control high current circuit with low current switching circuit. In ABS, relays are used to switch motor and solenoids. Occurs a low control signal from the control module energizes the relay that completes the electrical circuit for the motor or solenoid. So now we can see about the wheel speed sensor. The wheel speed sensor is something it is mounted near the different tooth ring. As the ring teeth rotate past the sensor, AC voltage is generated. As the teeth moves away from the sensor, the signal is broken until the next tooth comes closest to the sensor. The end result is pulsing a signal that is sent to the control module. So as you know, there will be many types of anti-lock braking system. So one of them will be four-wheel, force sensor ABS. That is nothing but it's the best scheme. There is a speed sensor on all four wheels and a separate valve for all the four wheels. With this setup, the controller monitors each wheel individually to make sure it's achieving the maximum braking force. This is one of the widely used braking system. And then we'll go for 3-channel and 3-sensor. This game is commonly found on the pickup trucks with four-wheel. The ABS has a speed sensor and the valve for each of the front wheel with one valve and one sensor for both rear wheel. This speed sensor for the rear wheel is located in the rear axle. So this is one type. Another 1-channel, one sensor ABS. This is commonly used on the pickup trucks with the rear wheel ABS. It has only a one valve which control both the rear wheels and then one sensor, one speed sensor located in the rear axle. So now we go to the what is the advancement in the ABS. Now coming to the automatic traction control. Automatic traction control, what it means? It actually applies the brakes on a driver wheel attempt to spin and lose traction. Okay, the system works best when one drive wheel is working on a good traction surface and the other is not. The system also works well when the vehicle is accelerating on a slippery road surface, especially when during climbing the hills. Actually, when climbing the hills, ADS is the most helpful on four-wheel or all-wheel drive vehicle, in which loss of traction at one wheel could hamper driver control. Okay, so this we can say by this. Now you can go for automatic stability control. Like ATC, the stability control system are linked with the ABS. It can also be called as electronic stability programming. The stability control system momentarily apply the brakes at any one wheel to correct over the steer or under steer. The control unit receives signals from the typical sensor pulse and sensor pulse, lateral directions and steering angle sensor. The system uses the angle of steering of the wheel. So the speed of the four wheels to calculate the path chosen by the driver. Okay, so now we go for what are the advantages of the ABS? So these are the main advantages of the ABS. As far as I know, it allows the driver to maintain directional stability and control over the steering during braking. That's the important thing here. Are safe and effective. It's safe and effective. Automatically changes the brake fuel pressure at each wheel to maintain the optimum braking performance. To reduce the braking resistance. ABS observe the unwanted turbulent shock waves and modulate the pulse, thus permitting the wheel to continue turning around maximum braking pressure. Okay, so disadvantage of the ABS. That's not a disadvantage actually. Nowadays we are widely using the ABS. So we have in everything we have some constraints. So the disadvantages in this are it's very costly, obvious it is. And the main of the cost of a car equipped with ABS is more. So in general. Okay. Now we come to the conclusion. ABS has been so far developed to a system which provides rapid automatic braking in response to sign of an incident wheel locking up, alternately increasing and decreasing the hydraulic pressure in the brake lines. Okay, the statistics shows that approximately 40% of automobile accidents are due to skidding. So we can avoid that by using ABS. These problems are commonly occur in the vehicle with conventional braking system, which can be avoided by adding the ABS system. If there is an ABS failure, the system will revert to a normal brake operation. This is on the plus point. Normally, the brake ABS warning light will be turned on and let the driver know there is a fault. Okay, so this is about the ABS, and this therefore I conclude my presentations in ABS. Thank you, everyone.